Okay, so we are going to move on to the last part of this section, which is about how humans have discovered how to use light to transfer information. We literally have the capability of transmitting information at the speed of light because we have learned to encode information um, into a light wave, which sounds super sci-fi whenever I say that out loud, but that's the world that we live in. And it's the world that has changed an incredible deal in the past 200 years since we discovered this technology. It's what has brought us together as a world. It's what has made the internet possible, wireless communication possible. It's why you all are tied to your magic rectangles, your phones 24/7. So we would not have the world as we know it now unless this technology was invented. I think a lot of good has come from it. I think a lot of bad has come from it, and I don't know. I think in a lot of ways it's changed us in terms of who we are as human beings. But I'm not going to wax all philosophical about that. Let's learn about the science. So we know that a light wave is generated when a charged particle is wiggled around, right? You guys remember the little simulation here. This is the electromagnetic field. A light wave is just the excitation, the wave-like excitation, a ripple in this field. I can put a ripple in the field by wiggling a charged particle back and forth. So it turns out that if we can wiggle charged particles back and forth good enough, in just the right way, we can create any type of electromagnetic wave that we want and send it out into the world and send it out into space and thus transmit information at the speed of light. All we have to do is encode the information into how we wiggle around the charged particle and encode the information into the light wave. Here's another simulation to show you what I'm getting at. We'll talk about the details of this a little bit, but imagine that we have a radio station, and here's the radio tower. This is called the transmitter. And then we have another thing over here. This is the receiver. The antenna is just made of a bunch of metal, which contain electrons that are very easily movable. The receiver does as well. By the way, this works exactly the same way in your phone. Your phone has really tiny, compact antenna inside, internal antenna. So your phone actually receives light waves. Those light waves wiggle around the electrons in the antenna of your phone, and your phone is capable of decoding that as digital information. We'll talk about that. But anyway, so here's a nice smooth wave. You can see the electromagnetic field is getting excited. It's getting wiggled around, and it goes out, and that causes this electron to get wiggled around. And so we've just sent the information. Now imagine the information is encoded in the frequency of this wave or something like that. Then we are capable of receiving that exact same frequency, the frequency with which this electron gets wiggled around, the frequency of this wave, and the frequency with which this electron gets wiggled around over here in the receiver. They're all going to be identical. So we've just transmitted information, right? It's exactly like what we were talking about with your ear a few weeks ago. Sound waves have a certain frequency that causes the tympanic membrane, your eardrum, to vibrate with the same frequency, and that frequency of vibration gets transmitted all the way down to your hair cells and to your brain. Well, it's the exact same way. We have a certain frequency here that's getting sent as a light wave at the speed of light, 3.10 times or 3 times 10 to the 8th meters per second, insanely fast as anything can travel in the universe, and that's oscillating, wiggling around this electron, and we can decode that signal as music or as a text message or pixels on a screen as video, things like that. Kind of crazy, right? So that's what this is all about. I'll go back to this and show you some more later. Let's talk about all the steps involved in sending a signal like this. These are the steps. Seems like a lot, but I think it's going to make a lot of sense to you. First of all, we have to get a signal, and we have to put that signal into our device. This would be like speaking into a microphone, what I'm doing right now. So the information comes in one form, such as a sound wave. That signal then has to get transduced, converted into electrical energy. That's what the microphone in my computer is doing right now. It's taking the vibrations in the air and turning them into electrical pulses, much like the hair cells in your ear. Then that information needs to get processed, and I'm using different words for this: modulation, processing, encoding. It needs to get kind of condensed down, converted into yet another form, a digital form maybe, a form that can be easily stored in and transmitted as a light wave. And then that wave needs to get transmitted. We need to create the electromagnetic wave. How do we do that? Well, remember, we cause a charged particle in an antenna to wiggle around. We use electricity and magnetism to do that. And then the wave actually gets transmitted and sent to the receiver. The receiver receives the wave, so we have reception. That's happening over here. And this signal is now in the form of electricity. Remember, moving electrons is a form of electricity, so we now have electrical pulses, and that has to get transduced back, where we convert the electrical energy into another form. So remember, up here we converted it into electrical energy, and now we're undoing that. And then finally we're going to put a signal out. So your speaker makes sound waves using the electrical information. So one more time, we put a signal in. It gets converted into an electrical signal. That electrical signal gets processed and placed into a version that can be transmitted through light waves. The light waves actually get generated, they get transmitted, they travel to the receiver, which receives them. And then the electrical information has to get transduced back to another form, such as sound. Your speakers do that, and then the speakers put out the signal. That's how information is transferred. And this exact process, I'm oversimplifying, but this exact process works for a text message, a phone call, an email, this video, anything that you do over any sort of data communication network. It works exactly like this. So let's talk about these processes. I'm going to use the example of how are you hearing my voice right now. This is kind of a simplified version of what I just said. Here's the signal. This is me speaking. It gets transduced, turned into electricity. It gets processed. It gets transmitted as an electromagnetic wave. In this case, because this is a video I'm recording, I'm not speaking this live over the radio or something. To simplify it, we're going to kind of pretend that I am, but it actually gets transmitted as wirelessly as Wi-Fi and gets stored on the YouTube server and all that stuff. But anyway, it gets transmitted eventually to your computer through light waves, and your computer receives it, processes the electrical signal, and transduces it as light on your screen. But because I'm using the example of my voice, as sound waves through your speaker. So this is what happens. Let's talk about microphones real quick. Microphones are what are initially receiving the signal and transducing the signal. So remember, transduction is taking one form of energy and converting it to another, aka one form of information to another. So sound waves come in with a specific frequency. They hit this movable part of a microphone called a diaphragm, and the diaphragm basically turns on and off an electrical signal using magnets. Remember, magnetism can give rise to electricity. Electricity can give rise to magnetism. They're related, so we can use a magnet here to help us. We're kind of moving the magnet in and out. Do you remember what happens when you move a magnet in and out of a coil of wire? Yeah, it creates an electrical current. So we are taking all the information encoded in the sound waves, the amplitude, which is the volume, the frequency, which is the pitch, of all the sound waves that my voice are generating, and that's getting transmitted into electrical signals, into electrical pulses. So if I'm speaking at a very high frequency, then there's going to be a very high frequency of electrical pulses sent. Make sense? So we're just translating. We're translating the language of sound, of vibrations, into electrical pulses. So that's signal in, and that's transduction. Then we need to actually process, modulate, or encode that information. This is the most complicated part of this whole process. So let me talk to you a little bit about that. First of all, let's discuss radio. Remember, radio waves are very long waves. Let's take one more look at the electromagnetic spectrum. Radio waves are very long waves. They have a short frequency, which means they contain very little energy. Radio waves don't take a lot of energy to create, which is very lucky for us because they're easy to create. That's how we like to transmit information. Remember, I think I said earlier that things that get transmitted through Wi-Fi, stuff like that. It's going to be some form of microwave or radio waves. Of course, if we're talking radio, then yeah, it's going to be radio waves. So we need to take the information. Remember, the information right now, where we last left it, is in the form of an electrical signal. So we need to take that information and we need to kind of encode it in a wave of light, in an electromagnetic wave. And for radio waves, there are kind of two processes known as AM and FM. I think you've heard of those. AM and FM. AM stands for amplitude modulation. So what we do is we take the electromagnetic wave, it's called a carrier wave, and the modulator basically takes the electrical information that the microphone made and converts it, stores it as a form of information based on the amplitude or the intensity of the light wave. So we have modulate. That word modulate just means change. So we have changed the amplitude. So now the information has been encoded in the varying amplitude of the radio signal. This is our radio wave that gets sent out. FM stands for frequency modulation. So the electrical information that the microphone has picked up is going to get translated into the language of light by changing not the amplitude of the wave this time, but the frequency of the wave. You can see the frequency goes from high to low to high to low to high, so we're changing the frequency. AM and FM modulation. This is information processing. We are creating an electromagnetic wave. We are encoding the information from my voice. It got translated by the transducing microphone into electrical signals. Those electrical signals get translated via modulation into electromagnetic radio waves or microwaves, or however it's being transmitted. Now there is another dichotomous type of information processing, which you're all familiar with, that you've heard of before, called analog and digital. So these are different ways, again, that information can get processed. Analog means it is an analogy. It's analogous to directly. So let's think about this. Let's look at frequency modulation. Let's say that the electrical impulse that got put into the frequency modulator was a high-pitched sound, me singing a very high note. Dear God, please no. But a very high-pitched sound. The frequency modulator is going to take that and change the electromagnetic wave that gets produced, going to send an electromagnetic wave with a very high frequency. High frequency of sound turns into high frequency of electrical pulses, turns into high frequency of electromagnetic radiation. In other words, the electromagnetic wave that gets created is analogous to, remember in your English class what an analogy is. An analogy is a comparison between two things. So it's directly comparable to the sound wave, high frequency to high frequency. That's analog. An analog signal preserves the waveform of the original signal. So high frequency sound wave results in a high frequency analog wave. Digital is what most information transfer processes take the form of these days in our digital era. And digital means digits. So what happens is that the sound wave gets converted into digital information, binary information. Instead of high frequency, low frequency, instead of these very smooth curves, we get either on or off, zeros and ones. And so the information gets encoded into a binary code, a digital code, digits, right, zeros and ones. So this wave, this analog wave, would end up looking something like this. This is an oversimplification. It's kind of complicated. I'm not telling you this is what the light wave would look like. There's no way for us to make rectangular light waves, but I'm telling you this is what the information would do.